Hello students, today's practical class we are going to understand how to compare the mutual inductance or a ratio of mutual inductance of the given pairs of the coil using the ballistic galvanometer, that is BG. Okay, you can see the circuit diagram. There are two resistance boxes P and Q and two sets of pairs of coils, and there is a commutator, power supply, and there are three keys K1, K2 and K. They all are wired up in the same way shown in the circuit diagram. Now using these components we can wire up like this. Okay, this is resistance box P and this BG, and this is resistance box Q, and this is K2, and here is K1, and this is secondary coil S1, and this is secondary coil S2, and this is primary coil P1, and this is primary coil P2, and this is commutator and the key K, and this is the power supply. To determine the ratio of mutual inductance, the secondary coil and primary coil must be paired up. Now it is not shown. The coils can be paired up like this. Bottom is the secondary coil, this is the primary coil. Similarly here, this is P1, this is S1. Initially the BG is adjusted with 0. To check the circuit, first of all key K1 is closed and K2 is kept open, and then the key K can be closed. Now you can see when closing how the BG shows the deflection. You can see it goes on left side. Next is the key K1 is kept open and K2 is closed. Now we can check the direction of BG by closing the key K. You can check now, it should go on. When I close the key, it should go on right side. You can see now. Once again. Now the circuit is ready for the determination of ratio of mutual inductance. Let's see the formula and tabular column. Okay, this is the formula we are going to use for the calculation of the ratio of mutual inductance M1 and M2, which is equivalent to Q2 minus Q1 divided by P2 minus P1, where P1, P2 and Q1, Q2 are the values of the resistances included in resistance boxes P and Q for 0 kick in the BG. Similarly, M1 and M2 are the mutual inductance values of the given two pairs of coils. Okay, through this tabular column we are going to record the observation. So you can see there is a combination of turns in the primary and secondary. It is P1 and P2 are arranged at 500 and S1 and S2 are kept at 400. Now we shall arrange the resistance of the P box as 100 ohms, and you can measure the kick in the BG, and simultaneously we can increase the value of the resistance in the box Q to make the kick 0 in the BG. For that we can record the observation. Similarly, the reading of the box P can be increased to 200, and similarly we can record the value of Q for 0 kick. Likewise, the experiment is repeated for 3 different values of P, that is 100, 200 and 300. To observe the reading, so initially we are going to keep 100 ohm in the P box resistance, and the key K1 is closed. Now we don't have applied anything in this Q box, and K2 is closed. Now by closing the key K1, this one, we are going to see the kick. You can see now when I close the key K1, it goes on right. Now to make this kick 0, we have to apply some value in this Q box. Okay, you can see the reading. It goes 12 or 13. Now I have applied some values in the Q box. I can see the reading has decreased. Likewise, I can increase the value in Q to make this kick 0. Now the values in the Q box is further increased, but still it shows some deflection on right side. But we have to make it 0 kick so that we can make note of the resistance in the Q box. Now you can see the keys K1 and K2 is closed, and for a particular value we have applied, that is 100 ohm in the P box, and relevant values are applied in the Q. Now I am trying for the 0 kick. You can see now almost it is a 0 deflection. So I am closing the key K now, but it shows with 0 deflection. That means we can record this value in the Q box. The observed readings are recorded in the tabulation as shown. For the first case, we have set the P values as 100, 200 and 300, and for 0 kick we have measured the values on left side and right side we have recorded. That is, there is a commutator in the circuit, and using the commutator we can record for both left side and right side of the deflections. So for every value in the P, similar value is recorded in Q for 0 kick. And the same experiment is repeated for second set of turns in the primary and secondary. That is, P1 and P2 is kept as same in the previous case, but S1 and S2, the S2 is changed. Now it is 300. For this second set of coils, same way the experiment is repeated. That is, for 3 different values of P. For 0 kick, the Q values are recorded on left side and right side using the commutator. The calculations can be done using the formula M1 by M2 is equal to Q2 minus Q1 divided by P2 minus P1. This is for the first set of reading. Similarly, for other sets of readings also the calculations can be done, and you can take the mean values of the 3 readings for the first set of coils, and similarly for the second set of coils. Before the calculations, the readings from the tabulation which we have initially recorded, that can be written in another form using this tabulation, like this P1 Q1 P2 Q2 can be separately written for the 2 sets of coils, and you can calculate. We have shown the calculations, and based on the formula and calculations you can fill this tabulation for M1 and M2, and you can have the mean values of M1 and M2 as shown. The compared values of mutual inductance of the given 2 pairs of coils can be given as shown.